For the next problem, we're given a block which is 1.2 by 1.2 by 1.5 centimeters, and we're asked for the resistance of the block depending on whether we have a square end or we have a rectangular end. So if we look at the square end, we know that the area is going to be 1.2 times 1.2 centimeters squared, and this will give us 1.44 times 10 to the minus 4th meters squared, because this would be times 10 to the minus 2 meters times 10 to the minus 2 meters. So we can do it that way if you want to. The resistance is given by the resistivity times the length over the area. And if we look up the resistivity of iron, we find out that it's 9.68 times 10 to the negative 8th ohm meter times the length. In this case, it's the leftover length, which is 1.5 times 10 to the minus 2 meters over the area, which is 1.44 times 10 to the negative 4 meters squared. And if we do this, we get a resistance of 1.0 times 10 to the minus 4 ohms, which is the same as 100 microohms. Now, if we do a rectangular parallel geometry instead of a square geometry, then the difference is going to be that the area now is going to be 1.2 times 10 to the negative 2 meters times 1.5 times 10 to the negative 2 meters. And that will give us 1.8 times 10 to the minus 3 meters squared. And then the resistance now, which is the resistivity times the length divided by the area, would equal 9.68 10 to the minus 8 ohm meter. The length now is the third one that's not being used, so it's 1.2 10 to the minus 2 meters over 1.8 times 10 to the negative third meter squared. And this gives us 6.5 times 10 to the negative 7 ohms, which is the same as 0.65 microohms. So there's a huge difference, as you can see, depending on which geometry is used.